Hello students, welcome to your science class. So in continuation with the chapter that we were studying, that is chapter 13 magnets, I, Shonali Biswas, your science teacher from your school Central Academy, Indiranagar, Lucknow, have brought part 3 of the chapter. Today we are going to learn about the properties of a magnet, Earth is a magnet, and a little bit about magnetic compass. So let's start with it. Firstly, starting with the properties of a magnet. There are 3 important properties that are exhibited by every magnet. That is the directional property, the attractive property, and the repulsive property. We have already discussed a little bit about all these 3 types of properties. So starting with the very first property, that was the directional property. Now this property states that whenever we freely suspend a magnet, it always aligns itself in the north-south direction. This property of a magnet is called its directional property. So the end of the magnet that is pointing towards the north is called the north pole of a magnet, and the end of the magnet that is pointing towards the south is called the south pole of the magnet. Now the second property of a magnet, that is the attractive property. Magnets always show attractive or repulsive property among them. The north pole of a magnet and the south pole of another magnet will always attract each other whenever they are brought close to each other. So this is called the attractive property of a magnet. Just the opposite of attractive property is the repulsive property, where the similar poles of a magnet, when brought closer to each other, will always repel each other, means they will push each other away. This is the repulsive property. Now coming on to an important topic of this chapter is Earth as a magnet. Our planet Earth behaves like a huge power magnet. Though it behaves like a weak magnet, but it exhibits the properties of a magnet. That is the reason that a magnetic needle, when suspended freely, as well as the magnetic needle in a compass, always points towards the north-south direction. You must have heard about the beautiful northern lights, which is also known as aurora. This phenomena is also formed due to the magnetic field of the Earth. This happens when the charged particles from the sun, it collides with the molecules of oxygen and nitrogen in the air. And because the magnetic strength is stronger at the poles, we are able to see this phenomena at the north and south pole of the Earth. The Earth's magnetic field is mostly caused by the electric currents in the liquid outer core that is made up of molten iron. So the loops of currents in the constantly moving liquid iron core creates the magnetic field. So this is why our Earth acts like a magnet, due to the constant movement of the molten iron. The magnetic poles are situated opposite to the direction of the geographical poles. So we know that Antarctica lies at the south pole. This south pole is the geographic south pole. But when we talk about magnetic poles, then the poles are reversed. Means Antarctica has the magnetic north pole, and Arctic Circle, it lies near the magnetic south pole. So the north pole of Earth's magnet is near to the geographic south pole of the Earth, and the south pole of this magnet is near to the geographic north pole of the Earth. So this is the reason why a freely suspended magnet always aligns itself in the north-south direction. So when a magnet is suspended freely, its north pole is attracted by the magnetic south pole of the Earth, and the magnet's South Pole is attracted by the magnetic North Pole of the Earth. Hence, it aligns itself in the geographic north-south direction, telling us the correct direction. What would happen if the Earth was without magnetic field? We all know that there are various satellites that are floating out in the space. So the first thing would be that all the satellites would fall down, and the astronauts that are living up in the international space stations will never be able to communicate back at home. Along with that, the charged particles from the solar wind that is coming out of the sun would strip away the ozone layer. And ozone layer is the one that protects us from ultraviolet radiations. It does not let ultraviolet radiations enter the earth. So as a result, we would all die due to the skin cancer. This is why magnetic field is very important for our planet Earth and us. Now coming on to the last topic, that is magnetic compass. What is a magnetic compass? Magnetic compass is an instrument which is used for determining the direction on the surface of the earth. It does so by the means of magnetic pointer that aligns itself with Earth's magnetic field. And what is this magnetic pointer? This is a magnetic needle. Soon after the discovery of magnetite, a simple compass was invented. This was done by placing a magnetic needle in a cork, and this cork was made to float in a water. After a few minutes of observation, this magnetic needle always pointed towards the pole star. Pole star is present at the North Pole. So this always helped in determining the correct direction. This is how the ancient compass was invented. The magnetic compass is the oldest type of compass which was used in different forms in aircrafts, ships and land vehicles, which were used by sailors and explorers. The outer case of a compass is made up of non-magnetic materials such as aluminium, brass, plastic or glass. If the outer case was made up of a magnetic material such as iron, then the needle would have deflected and it would have been attracted by the outer case, telling us the wrong direction. Hence, it wouldn't have been useful to us. So that's all for today. Tomorrow we will finish our rest of the chapter. Till then, thank you and have a nice day.